welcome to CodeChef. In today's video, I'm going to be discussing a problem, sharing is caring. It is a practice problem with a code of ECJN202. You can find it on CodeChef, and it would be really helpful if you go and try to solve the problem first, and then if you're unable to, then you can come back to the video editorial and see how I'm solving it. Its prerequisites are mathematics. More specifically, you're going to need to add the array elements. So you need to know how to add elements, and modulo, which means you need to know the remainder operation in any language. So those are the prerequisites. You need to know those before you come into this video. Its difficulty, the difficulty of the problem that is Cakewalk. That means it's a very beginner friendly problem. And I'm going to move ahead to the problem statement now. Okay, so the problem statement, as you can see, is on the screen. It says that there are n friends in a group. Each of them have AI candies. Can they share all of these candies among themselves such that each one of them have equal number of candies? Later on, there is a format given which says that the first line you're going to be given is the number of test cases. The second line is going to be the number of friends, and the third line is going to contain n, that is n is the number of friends. So the third line is going to contain n integers, which are going to be a of I, for I ranging from 0 to n minus 1 in a zero-based indexing. They're going to be the chocolates, the candies that each friend has. Now, for each test case, you either have to output yes or no. Yes, if you can distribute the candies equally amongst the friends, and no, if you can't distribute the candies equally amongst the friends. The limits are 10 for t, 100 for n, and 1,000 for the number of candies. So what can be the maximum possible sum? If each of them has 1,000 candies, then 1,000 times 100 can be the sum, which means 10 to the power 5. So 10 to the power 5 is obviously less than 10 to the power 9, so it can be held in the data type int itself. You don't need anything special. Now we'll go to the time complexity once we've seen the approach. So we'll need these constraints there as well. Let me just explain the example ones. So the first line gives the number of test cases. It is 1. That means only one test case will follow. These two lines describe the first test case. The first line of this test case indicates the number of friends that are present. It says 3. That means 3 friends are present. The next line contains 3 integers which tell you the number of candies with each of these friends. So the first friend has 1 candy, the second friend has 2 candies, and the third friend has 3 candies. Now, can they be equally distributed amongst all the friends? So the total number of candies is 6, and there are 3 friends. So obviously, if you give 2 candies to each of these friends, they will be equally distributed. So you output yes. Let me show you how I mean 2 candies to each friend. All right, so you had 1, 2, and 3 candies. That means a total of 6 candies. So if you give 2, 2, and 2 to each of these friends will have an equal number of candies. 1, 2 plus 3, 4 plus 5, 6. So total 6 candies, and it is distributed equally amongst the friends. That's why you output a yes. So now that hopefully you've understood the problem statement, I'll go over it again in short. You are given n number of friends and the number of candies each of these friends has, and you have to output yes if these candies can be equally distributed amongst the friends, and no if they can't be equally distributed amongst these friends. So let's move towards the approach. Now what I'm essentially going to do is I'm going to find the sum of all of these an. That means a0 to an minus 1 in a zero-based indexing. This is me talking about a zero-based indexing. That's why I'm saying a of 0 to a of n minus 1 instead of a of 1 to a of n. Now I'm using a zero-based indexing because it will be more convenient when you access elements by the indices. So it's better for the understanding in any language, since the indices usually start from 0 and not from 1. So what I'm going to do is I'm going to find the sum all the way to an minus 1. So I'm going to find the sum of all the candies, the total number of candies that each of them has. So once I have all the entire group of candies that each of them has, I need to divide it into n equal parts, right? So if I call this variable as sum, I need to check if I can divide sum into n equal parts. Now, if sum can be divided into n equal parts, that means the remainder of sum with n would be 0. So it will not give a remainder, right? For example, since 6 is divisible by 3, that means 6 candies could have been divided into 3 parts. The remainder of 6 by 3 is 0, the quotient being 2, right? So the quotient is 2 and the remainder is 0. So if the total number of candies is divisible by the number of children, that means the remainder is 0, which also means that the candies can be equally divided into all these children. So that is all you're going to have to check in the code. You have to find the summation of ai for I equal to 0 to n minus 1, and you have to see if this is divisible by n or not. If it is divisible, you will output yes. Otherwise, I should have just written else, but anyways, otherwise you output no. That means it will not be divisible amongst n friends equally. So let us see an example of that also, right? If I had candies which went something like this. So one of the friends has 2 candies, the other one has 2 candies, and the last one has 3 candies. How many total number of candies are there? 7, right? And there are a total of 3 friends. So is 7 divisible by 3? It will give a quotient of 2, but a remainder of 1. So since there is a remainder, 7 is not divisible by 3. So it's not equal to 0, right? So that means you will output no. Now you can see that these candies cannot be equally divided into 3 parts, because no matter how many candies you give to the first 2, like if you give equal number of candies to the first 2 is what I'm meaning to say, then the candies with the third one will be a number greater than the other 2. If you try to give 3 candies to each of these 2 friends, then the third friend will get less number of candies. So you can try various combinations if you want to, and you will see that it is never going to be equal to divide 7 candies into 3 equal parts. Now, this is exactly what we are going to implement in the code. So let's go towards the code and see how that is done. So I've already submitted a code and it has given a correct answer. So this is called an AC verdict or an accepted verdict. It says correct answer. That means all of the test files that were present in the system have ran correctly on my code. So they've given the correct expected output on my code. Now here, let me show you a submission that I made so that you can understand the code better. Here is one of my submissions. So the initial part is just the macros that you do not need to care about. They are not used anywhere in the code. The important part starts from my main. So the first thing I'm doing is taking t as the input. The initialization is of no consequence. I'm taking the input for t irrespective of the initialization. So it doesn't really matter what you initialize it with, or just leave it as it is. I'm taking t as the input. That means the number of test cases. And then I run a while loop for 0 to t minus 1. This is equivalent to running a loop from 0 to t minus 1. So while t is greater than 0, I call the function solve. Inside solve, what I do is I take n, that is the number of friends, into a variable. I declare a single variable. Instead of an array, I declare just a single variable a, because I'm not reusing the number of candies of each friend. I just need them once for adding, right? Now this is the variable, su is the variable that will store my sum. So the sum of candies with each of the children is going to be stored in this. So pardon me if there is friends written in the question and I'm saying children. I hope you're able to understand it either ways. So I run a loop for 0 to n minus 1, and I take the value of C in from my input. And I add this C into the variable Sue. So I'm adding all the candies into this variable Sue, right? The value of A will be updated each time I take it in through the input. Now, once I'm done taking all the values and adding them to a single variable, I'll see if the remainder that the variable gives, the sum variable gives with n, is 0 or not. If the remainder is 0, that means sum is divisible by n. That means it can be divided into n equal parts. So I will output yes if it is so. Otherwise, I go into my else statement and I output a no. That's it for the code. Now let me tell you about the mistakes. So I have a code for that as well. I'll pull that up for you and show you the mistake that I myself did in the first few submissions. So the first one is forgetting to take the number of forgetting to loop over the number of test cases. So I just called solve once. Now this wasn't a genuine mistake. I actually it was from one of the earlier submissions from one of the earlier videos, and I forgot to uncomment it. So it is also a mistake that is done with a lot of beginners. So that's why I'm mentioning it here. A special mention, however, would be the study of cases. So what happens is the question does not talk about the case of the answer. That means the answer output is going to be case sensitive. That means if the question expects you to output a capital Y with small e and s, then that is exactly what you have to output. You cannot, let's say, output Y capital E capital S or Y capital E and small s. If the question says capital Y and small es, then that is exactly what you have to output. So the submission is going to be case sensitive, which means if you output this or this, then even if yes was the correct answer, you're not going to be given an accepted verdict. You will be given a WA verdict or a wrong answer verdict. That means your code could not pass all the test files that were present on the system. So same goes for no as well. It is said that you need to output a capital N with a small o. So that is exactly what you're going to have to output. You cannot make it this way or this way. So capital O or capital N and capital O, it won't work that way. If it is said that you need a capital N and a small o, then that is exactly what you have to output. So yeah, case sensitivity was another thing that I wanted to mention. Apart from this, there is also the problem of considering 0 into your exceptional cases, like it is nowhere mentioned in the question itself that if the sum of the candies, if the total number of candies just remains 0, then you can't divide it equally. It is nowhere mentioned, right? Because essentially if the number of candies is 0, then each of the n children can be given 0 number of candies. So they can all be given equal number of candies. So do not output no in case the sum comes out to be 0. I saw this in a few solutions. That's why I'm making sure that I mention this. If the sum is 0, that means the candies are still equally divisible amongst the n children or friends. So this will be a case in which you output yes, not no. Keep that in mind. And with that, I think we've come to the end of the mistakes. Yeah, so now, like I talked about the time constraint, right? I was going to talk about the time constraint. T is 10, N is 100. Let's take a look at that. Now, T is 10 and N is 100. These are the maximum values that I'm mentioning over here because they determine the upper bound of the time that you're going to need for your code to run. Now, for each test case, you are running a loop for 0 to n minus 1. So you're running over all of the n elements that are given to you, right? So you're definitely needing this 100 in your time complexity considered. It is also said that you can be given 10 test cases at maximum. So that means 10 times 100, that would make it 10 to the power 3. So this can be your worst case complexity, 10 to the power 3. The time limit that was given for the question. Now, AI is of no consequence here because you're not doing anything with the value of AI except for adding it. So it is not contributing to the time complexity. Now, like I said, the time limit for this question, as you can see, is 1 second. So big O of 10 to the power 8 is close to 1 second. Let me just write that down. 10 to the power 8 is close to 1 second. Now, since your complexity is just 10 to the power 3 of the order of 10 to the power 3, that means it is way less than 1 second. So it will be easily accommodated into the time limit that is set for the question. So you need not worry about it. Now, I guess that's about it for the question. Thank you so much for watching. I'll see you next time.